So I'm gonna go through
Oh, okay.
a couple, yeah. So first I want to discuss what qualifies a triangle, because as we've seen there are many different types based on their sides, some being the obtuse is based on their angles, so I'd like to discuss that a little bit. So triangles, they're closed figures constructed from 3 line segments. So if I take any line segment, I want to have 3 of them that all connect. So we had the right triangle from before, a scalene. They're all connected by 3 line segments. Their interior angles add up to 180 degrees. So for it to be a triangle, that means all 3 of these angles, or all 3 of these angles, or any triangle you draw, the 3 of them will add up to 180 degrees. If it doesn't, then it's not a triangle. There are different triangles based on their angles. So we talked about the equilateral. I meant to say their sides. I did a typo there. Sorry. Equilateral triangle, isosceles triangles, and scalene. This is supposed to say sides. So if you write it in your notebook, that is a typo that I made. And then there's also triangles based on their angles. So acute angle triangles, obtuse angle triangles, and right angle triangles. So there are many different types that we will discuss today and in following classes. So the first one we'll discuss is a right triangle. So as previously said, this triangle has that little square that would usually be right here, which means what? Edwin, do you want to revoice what you said earlier?
Yeah, it means that angle is 90 degrees.
Yeah. So that would make a right triangle. So any triangle that has at least one angle that is 90 degrees would be a right triangle. And then there's also different types of special right triangles. So you'll see things that are 45, 45, 90, or 30, 60, 90. These are based on the angles. Like I said before, this is one of the triangles based on the angles, not the sides. So for example, this one is 90, as we said before. So the special right triangles, one of them is this angle and this angle are both 45, and the other one is this angle and this angle. One would be 30, one would be 60, and that would be 90. Since when you add those 3 numbers together, in both cases add up to 180 degrees. So another type of triangle is the isosceles triangle, as we discussed before. Yeah.
I had a question on the last
Yeah.
slide, sorry. What makes them like special? Is that just like, are those the only way that right triangles can be? Or is it just that like?
Those are just well known, so they
Okay.
occur often. I mean, you could have other triangles. Like I said, they have to add up to 180 degrees. So if you had the 90 degrees here, and this was 46, and that was 44, it still adds up to 180.
Okay.
But the 45, 45, 90, and 30, 60, 90 happen more often.
So they're just the most common?
Yeah.
Gotcha. Thank you.
You'll see them occurring a lot in class. So then the isosceles triangle, this means that the triangle is having 2 equal sides in length. And so earlier, what were we saying were those little indicators that we would know if they have equal length? We saw on one of the pictures.
There are lines going through.
Yes, so in this one, do you know where the lines would be going through in this one?
The 2 going on.
So these 2? Yeah. So exactly. So this drawing doesn't have it, but there would be a line here and a line here, since these 2 lengths are the same. Also up here says the angles opposite of the equal sides are equal. I know that sounds really confusing. This just means, so we said that these were the 2 equal sides. So if I look at this side, I want to look at the angle opposite. So if you think opposite, what do you think of?
The other side.
The other side, so like across. So I'm going to go here, and I go across to this angle. So this one, I'm going to go across to that angle. It's depicted in this picture. You can see the double bars. I don't know how hard it is to see it over there, but there's double angle symbols in both of these sides, meaning they have the same angle length, or same angle measurement. Any questions on isosceles? The next one is scalene. This one is not seen as often, but it is something that will come up. This just means it has 3 different side lengths and 3 different angle measurements because of the 3 different side lengths. So this is showing this side has 1 length, this is a different length and this is a different length. And then these angle measurements are showing the 3 different types of angle measurements because they're not, none of them are the same. And then another word is hypotenuse. This is how you would describe a right triangle. So this slide and the next slide is all talking about right triangles because they will become very important. As we'll learn in the future, we'll learn an important theorem that has to do with just right triangles, meaning a triangle with 90 degrees. So the hypotenuse is the longest side of a right triangle. So in this one, you can see that the right angle is right here, and the hypotenuse is always going to be opposite of the right triangle, or the right angle. So here's the right angle, opposite is a hypotenuse, and like I said, that is the longest side of the triangle. Any question on hypotenuse? And the next one is legs. They're called different things. You're going to hear legs, sides, whatever works for you, call it whatever. On this one, I just said legs. So those are the other sides of the triangle. So if I have this right triangle, we just discussed the hypotenuse is opposite of the 90 degrees, and it's the longest side of the triangle. The legs are the other 2 sides, so they're shorter than the hypotenuse, and they're opposite of the acute angles. So acute angle, that is something, if we remember from previous classes, it's an angle that is less than 90 degrees. So if this is 90 degrees, we know that these 2 angles, the sum of them, so if I add them up, these 2 will equal 90, because it's 90 plus 90 is 180. So these have to be less than 90, making them acute. So opposite of this angle is one of the legs, opposite of this angle is one of the legs. Does that make sense? I can rephrase that if it doesn't. So that's the last slide in this PowerPoint. Does any of the triangles, anyone have questions about them? Later, I know we saw some obtuse triangles and acute triangles someone brought up. We'll talk about those in future lessons. These are just some of the basic triangles. If not, if you guys want to take out just a half sheet of paper or whatever, we have a little exit task for this, and I will write it on the board.